So in this question here, we're asked to show that the equation x cubed plus x equals 7 has a solution between 1 and 2. So looking at the equation here, we're basically told that there is an x value between 1 and 2, which, if we substituted it into the left-hand side here, would give us the value of 7. What I'm going to do to begin with is just to maybe get this equation in a bit more of a more recognisable form, a form that's going to be easier to work with. So if we have x cubed plus x is equal to 7, if we were to subtract 7 from both sides, we'd be left with x cubed plus x minus 7 is equal to 7 minus 7, which is 0. So I'm moving the 7 onto the left-hand side by subtracting 7 from both sides. Now we've kind of got an equation that might look a bit more familiar. So we've kind of got an equation over here and we're setting it equal to 0. So if we're looking for a solution between 1 and 2, well, to show that there's a solution here, we need to show that this equation over here has a solution between 1 and 2 similarly. And the way that we can do that is by subbing in the values of x equals 1 and x equals 2, so the bounds here, and looking at the values that we get out and seeing what they are in comparison to this 0 that we're looking for, where the root is, where the solution is. So if we take x is equal to 1, substituting that into the left-hand side of this equation, 1 cubed plus 1 minus 7 is equal to 1 plus 1 minus 7, and that's going to give us minus 5. And then similarly with x equals 2, we have 2 cubed plus 2 minus 7. 2 cubed is 8 plus 2 minus 7, and that gives us 3. So we've got these values out when we sub in x equals 1 and x equals 2, and we just need to work out what they mean and what they show. So we're looking for a value of 0. So when the x value is the solution, when we substitute that value into here, we're going to get 0. However, when we use 1 and 2, we get a value of minus 5 and 3. What I'm noticing here is that we have a negative when x equals 1 and a positive when x equals 3. Minus 5 is less than this value of 0, and 3 is greater than this value of 0. So, what we can write down is that there's a change in sign. So this is going to imply that therefore a solution lies between 1 and 2. And that's because we've set the expression equal to 0 and we've got out a negative and a positive value, so somewhere in between them we must have the value of 0. So the solution is going to lie between 1 and 2 because those were the x values that we put in. And the graph's continuous, so if we were to draw out the graph of this, we'd be basically looking for the root of the graph, so where it intersects the x-axis, and we have that change of sign here. So some point between x equals 1 and x equals 2, there is going to be a solution, and we've written that down here. So the first mark is for substituting the values of x equals 1 and x equals 2 into this expression here. Similarly, you could do it and leave it as x cubed plus x and then say that the values that come out, which are 2 and 10, one's greater than and one's less than 7. That also works, but sometimes I just find it a little bit easier to work with it in terms of something equaling 0, so we can clearly see the change in sign, so the negative to positive. And the second mark here is just for this little explanation at the end and getting out the correct values of minus 5 and 3, or 2 and 10, and explaining why this shows that there's a root or a solution between 1 and 2. Now in this question we're asked to show that the equation x cubed plus x equals 7 can be rearranged to give x equals the cubed root of 7 minus x. Now initially what I'm realising here is that we have a cubed root in this expression that we're trying to find, and over here we have an x cubed. So if we can get some expression equal to x cubed, when we find the cubed root of it, we're going to have x equals something. So taking this expression, x cubed plus x is equal to 7. If we subtract x from both sides, we're left with x cubed is equal to 7 minus x. And this is looking familiar here because we have the 7 minus x under the cubed root sign. Now we have x cubed is equal to 7 minus x. What we can do is find the cube root of both sides of this equation. Remembering to do the same thing to both sides of the equation. And then if we look over here, the cubed root of x cubed is just x, because if we cube x, we get x cubed, and that's equal to the cubed root of 7 minus x, which is what we were asked to show here. And that will get us the mark for this question. So now for this part of the question, we're asked to, starting with x0 equals 2, use the iteration formula xn plus 1 is equal to the cubed root of 7 minus xn, which is the equation that we rearranged to find in part B. We're asked to use that iteration formula 3 times to find an estimate for a solution of x cubed plus x is equal to 7, which is the equation that the iteration formula has come from. Now we're asked to start with this value, x0 is equal to 2. So if we let x0 is equal to xn, so we're starting with n is equal to 0, what we do to find x of n plus 1, so 0 plus 1, so x1 is going to be equal to the cubed root of 7 minus xn, which is x0. So just to go through that again, we have xn plus 1, and n is 0, so n plus 1 is 1. So x1, next term, is equal to the cubed root of 7 minus x0. And we have the value of x0 that we've been asked to start with. So the cubed root of 7 minus 2 is equal to the cubed root of 5. And if you put that into your calculator, that's going to give you an answer of 1.709975, etc. And it's really important to use the exact value throughout this question to then substitute into the next part to make sure we don't get any rounding errors throughout the question. We can then go on to find x2. So this is xn plus 1 when n is equal to 1. So finding the cubed root of 7 minus x1 this time. So the cubed root of 7 minus this value that we calculated before, but use the exact value that can be stored on your calculator. And if we find the exact value of this, it will come out with an answer of 1.74241, etc. And then we can use this exact value again, keeping that stored in our calculator, to find x3. So that's using the iteration formula 3 times, finding the cubed root of 7 minus x2, and that's the cubed root of 7 minus x2, which is this value, 41. And that gives us a final answer of 1.7388, etc. However, what I'm going to do is just round that to 1.74 in this instance. We're rounding up because 8 is greater than or equal to 5. And I'm going to give that as a final answer to 2 decimal places. So as for how the marks are awarded for this question, the first mark is for a substitution of 2 into the formula. So substituting 2 in and getting out this value here of 1.7099. The second mark is for a substitution of x1 to give x2, so this point here. And then the third and final mark is for an answer in the range of 1.738 to 1.74, and we've given that here correctly as the final answer of 1.74.